What's up guys, Major Math with another video on fluid mechanics. If you have any questions, drop it in the comments, and if you're having trouble with other problems, I've attached my email in the description, so please feel free to reach out. Without further ado, let's get started. Question 3.101 says, as shown, a round viewing window of diameter d equals half a meter is situated in a large tank of seawater with a specific gravity of 1.03. The top of the window is 1.5 meters below the surface, and the window is angled at 60 degrees with respect to the horizontal. Find the hydrostatic force acting on the window and locate the corresponding center of pressure. Okay, so when it says, or our first step always is goal, right? So let's do goal. Alright, so our goal is to find hydrostatic force acting on the window, so force of pressure, and locate corresponding CP. Locate center of pressure. Okay, and then our givens might write on this diagram too a little. So we got, says specific gravity is 1.03 for seawater. And then it says the top of the window is 1.5 meters below the water surface, so that's right here, 1.5 meters. It says 60 degrees, and then diameter is half a meter of this window right here is circular. Okay, so first things first, let's take the specific gravity and find the specific weight of seawater. So again, specific gravity is the specific weight of a liquid, and then the specific weight of H2O at temperature of 4 degrees Celsius. Let's rearrange this. So I'm going to put SW for seawater equals the specific gravity times, I'm just going to do it all at once. So it'll be specific gravity times the specific weight of water at 4 degrees, and I'll just go ahead and fill this in. So specific gravity is 1.03, no units. And this is 9,810 newtons per meter cubed. And then if you put that in a calculator, you'll get that the specific weight of seawater is 101,043.3 newtons per meter cubed. So that's the specific weight of water, seawater. Okay, so it says we need to find the hydrostatic the hydrostatic force, right? But which is also the same thing as the pressure force. So that'll be our first step. We're gonna find the force of pressure. Okay. So that formula is right here. Pressure force equals pressure times area. The little bar means in respect with the centroid of whatever we're calculating. In this case, it would be the little window. And also rewrite that as pressure is also equivalent to specific weight times the height. I'm writing Z for height. Little bar means the centroid again of the window, and then put times area. Okay, so we already know this variable. Now we need to figure out the height from the surface of the seawater to the centroid of the window. So let's calculate that real quick. So we're going to draw a little triangle. So we have this is our window right here. This is our circular window. That's what that hypotenuse represents. So we know that this is 0.5 meters. That's the length of that. We don't know this length, but that's what we're trying to figure out, right? So this is, we'll just label that X. And we know this angle is 60 degrees. We made a right triangle, so we know this is 90 degrees. This is 90 degrees minus 60, so this is 30. That leaves us with 60 degrees right there. Going back to trigonometry here, if we want to find this x value, we can do sine 60 equals, and sine is opposite over hypotenuse, so like that. So we know that x is equal to, I'm going to rewrite sine 60. If you think about the unit circle, sine of 60 degrees is square root 3 over 2 times 0.5 meters. You get x is square root 3 over 4 meters. So then that means, I'm going to label this. That means the z is equal to this height right here, because we're trying to find, and then we're trying to find the centroid, the height of the centroid. So we'll do 1.5 meters, so it goes down 1.5, and then we have to go down to the centroid of the window, so that will be adding this number we found and then halving it. Yeah, so I just took this number and halved it so we could find the centroid of the circle, and then that would give us, I'll just leave it as that. We'll plug that whole value in. Okay, and then we found z, the height. Now we gotta find the area. So the area of a circle is pi r squared, or if you're using diameter, you can do pi over 4 diameter times diameter squared. We know diameter is half a meter, so the area of a circle is pi over 4 times half a meter squared. So let's go ahead and plug in everything we know to find this pressure force. So we got 101.04.3. This is the specific weight of seawater. Then we have the height to this, from the surface of the water to the centroid of the window. Then we got the area of the window. Okay, put that on a calculator. You'll get a pressure force of 3,405.5 newtons, is equal to about 3.41 kilonewtons. Okay, so that's our pressure force on the window. It also says we want to locate the center of pressure. Okay, so locate CP, center of pressure. To do that, we have to use this formula that says, I'll show you guys on the textbook. 1 second. F.2, useful table. Oh, it might not have it on here, huh? I just thought it did. It has to have it on here. Oh yeah, it's right here. Okay, I'm tripping. Alright, so it's right here. It says the slant distance of the center of pressure minus the slant distance from the centroid with respect to the surface of the liquid equals the, oh, I forget what that's called. The moment of inertia, yep. Moment of inertia over the slant distance from the centroid to the surface of water times area. Okay, so we got slant distance, center of pressure. Don't put a bar over this. That doesn't have to do with the centroid. And you guys can't see. Okay. And then we got y bar, slant distance, moment of inertia over. Okay. Let's rearrange this. Put, because this slant distance will, that's our location of the center of pressure. Okay, so don't have it printed out, but figure A.1 in the textbook gives a lot of moments of inertias, and I think gives centroids of different shapes. But figure A.1 in the textbook says the moment of inertia for a circle is pi r to the fourth power over 8. And then we know that the radius is half of diameter, so we know that the moment of inertia is 0.25 meters to the fourth power over 8. So that's our moment of inertia. Our area, we already found that actually. We can just use the same area that we found earlier. Now we got to find the slant distance from the surface of the seawater to the centroid of the window. So we got to draw another triangle for that. So finding slant distance to centroid, draw this triangle. So we already know, my thought process on this is we already know this slant distance, right? We already know this at that 60 degrees. We already know that that is half a meter. Now we gotta find the slant distance here to get us to that surface of the seawater. So I'm just gonna be drawing. This is bigger than I wanted. That's okay. 60 degrees. And then we know this is 1.5 meters. We're trying to find this distance. This is a right triangle. And then we know this will be 30 degrees. 90 minus 60 degrees is 30. And then 180, we know that the angles in a triangle add up to 180. So 180 minus 90 minus 30 leaves us with 60. So it's basically the same triangle we drew earlier, but there's a number here, and we're trying to find the hypotenuse. So we can use sine of 60 again. So sine of 60 degrees equals opposite over hypotenuse, so 1.5 meters over x. Rearrange that. We'll say that x equals 1.5 meters over sine 60. And that gives us, let's see, yeah, we'll just leave it. We'll just leave it like that, and then we put it in our calculator. Okay, so slant distance will then be that diameter plus 1.5 meters over sine 60. That's all I wrote. That's our slant distance. We just found it. So now we actually know everything, and we can calculate the slant distance. So of the center of pressure. So we know we just found it. since we know everything, I'm just gonna let you guys plug it in yourselves. So y bar is here, it's the moment of inertia, and then the area we already found. So I'm just gonna be plugging all those numbers in without writing it out, and you should get an answer of 1.99 meters. If your teacher doesn't want the slant distance, they want just a regular vertical distance, you can draw another triangle to find it. I'll show you guys how to do that. It's going to be basically the same thing. We got our angle of 60 degrees here again. We got trying to find this value. We have our slant, which is 1.99 meters. So we know this is 60, this is 30, right? Sorry guys, it's probably not the best. Okay, and then so we can do sine of 60 equals x over 1.99, and then multiply sine of 60 by 1.99 meters, you'll get x is equal to 1.72 meters. So, and you know what, I'm going to change this, that doesn't make much sense. I'll put height. So the height of the center of pressure of the circular window is 1.72 meters below the surface of the seawater. Thanks for watching, soldiers. Don't forget to leave a like and subscribe for more content like this. If you have any questions, leave it on the comments, and if you need help with any other problems, feel free to contact me with the email shown on the screen.